Hello and welcome back. My name is Amir, and in this video we're going to continue our journey in the Codewars website and solving like a few puzzles on the level 7. Okay, here I am. I have set the difficulty to level 7 and let's do some coding. So I will grab this one and this one and skipping this one because it's like 10 stars. Let's go to this one. So, okay, this one says that max sum between two negatives. You have a list of integers. The task is to return the maximum sum of the elements that are located between two negative elements. No negative elements should be present in the sum, and if there is no such sum, return -1. Okay, so if we are starting from here, first we need to find the first index. Then we move on to find the second index, get the sum, which is 6, store it. Then we would go to the next. So this will become our first index. Then we search for the second one, which is -7. Find the sum between these two, 8. Compare it to the old sum, which was 6. 8 is bigger, we keep 8. Then this becomes our first index, and we search for the second one. We can't find any. Our biggest is 8, and we return that number. Okay. So let's go and do the coding. Let's train. Grab this part. Come here. Okay, so first thing is that I need to have the index for the negative number that we have found. In the beginning it's 0, and I need to store the max sum, which in the beginning is also -1. So we have two -1, which means that we haven't found any index, we haven't found any minus value, and we haven't found any sum yet. Then we would search to find the first index. So as you can see, we will skip all the positive ones. So I can say that for the I going from A until from 0, until A is less than length. In this case, only if that item is negative is when we care about that. We don't care about the positive ones. We just need to find the index, this one and this one. So if it is found, then check. Have we already found any index beforehand or not? If we haven't, so then this will become our lower bound or our index, so to say. So if index is still -1, then index, which is our lower bound, will be the I. Now we have found our first or lower bound negative number. We need to search and find the next one. Else sum is the A, and then slice it from 1 after the index, so index +1 and I. Slice it between these two, give me a new array, and then I will reduce that array to a number. The reduce function will have an accumulator, or others will call it the previous value. So this is an accumulator, and the v, which is the item in the array, just like the map function or filter function on the array. So this reduce will be working on all the items, and it will keep adding all the items to the ACC, and it will return the ACC in the end. and the first value for the ACC is 0. So this will give us the sum of all the numbers. So we can log it here, so log sum, and let's call this function and give it some number like this, some array, sorry. So it would give us 6 in the beginning and then 12. So 6 is correct because this is the 6, and 12 is not correct because it will go on and we will not resetting this one. So when we find 6, we need to say that okay, our lower bound is now this index. So I can remove this part. I need to do two more things. First, set the index to be I. Now the lower index is this one, but before that one, please check that if the max sum is bigger than the sum, then substitute it. So I can do it using the max function and give these two values to it. So max sum and the sum. This is like the same as saying if max sum is less than sum, then max sum is equal to sum. So this is doing it in one line. And then in the end, the index is I, as I told you. So when I found this and I found this and I did the max, then I would move the index from here to here, and I will continue from this index onwards. Okay, so I think this is basically done. I can here, after the for loop is done, then return the max sum, and I can here just log this value, and it's 8, which is I think correct. Yes, it's correct. So let's grab this function all together and copy and check if we are doing it right or not. So let's attempt it in one go, and yes, this was correct. Awesome. So this one is done. Let's go to the second one. Okay, it says that this is a page replacement algorithm, first in first out. It has talked about the first in first out algorithm, but the thing is that we need to implement this algorithm. So how does this work? It's like this. We have a list of the reference as it's here. It's like the number of the page, and our memory can keep only 3 pages. So we would go to the first, we read the first one, the memory will keep the first page. Then we read the second one, the memory will add the 2 to the list. We go and read the 3, which is this one, we add it to the list. Now it's getting interesting. We read 4, our memory is full because it has already 3 items. We remove the first one, or the oldest one, so to say. So our memory becomes 4, 2, and 3. Then we read 2. 2 is already in the memory, so we don't need to add it to the memory, so nothing will happen, as is described here. And then we have 5. We read the 5. We don't have 5 in this array, so we will remove the oldest one, which is 2, and the final array will be 4, 5, and 3. So we need to implement this logic here. So let's go and do that. I will remove everything from here, go back, go here, grab this function and come back. So first I will create my memory, which is an array of the size n, which is defined here, and at first I will fill it with like -1 or 0. and I would say that the position is for now 0, or the index in the memory is 0. And then for all the items in the reference list, we would do some logic as we described. So I would say for, let's use for let of. So I would say for let item of reference list, if that item is not in the memory, so if not memory that includes that item, we need to add it. So we would say that memory at index position is that item. So we need to update the position here as well, and that is done by like adding 1 to the position and then divide it by the n. So if position was 1, it will be 2. If it was 2, it will be 3. Divided by 3, it will be 0. Okay, when this everything is done, we can return the memory in the end. So here we can say that return the memory. And I believe this is the whole logic. So let's go back here and see if we did it right or not. Yep, so this one is fixed as well. Pretty simple. Let's go to the last one, which is this one. You need to create a function hello world that will return the string hello world, okay, without actually using raw strings. This includes quotes, double quotes, and template strings. You can, however, use the string constructor and any related functions. Okay, so let's see how we can do that. Train. So I believe we can use the string and give some regex to it. So if I go here, so let me grab this one, go here and paste. Let me say that result is string, and carefully use the like regex like this. So hello world. And if I log the result and here run the function, so yeah, I get this result, but I need to remove this first and last slash. So maybe I can say that after this, just like slice it from 1 until -1. So I think this is only this, and instead of just defining a variable, I can just return this. Back here and attempt. Yeah, okay, cool. So let's see where we are here now. Okay, cool. We have solved like 3 puzzles today, and in the next video we will continue going forward. So thank you for watching and see you in the next video.